John,
all right, so if you guys are paying attention and keeping record, today we are doing increasing and decreasing functions of the first derivative test.
Wait, is it recorded?
Yes, this is recorded. That's what I just talked about.
Is the audio recording?
Yes.
I didn't know it. Wait,
Can I do a shout out?
did they record the intro?
That's what I just asked you if you wanted to do the intro for this.
Can I shout out my Snapchat?
How about no?
Damn.
Subscribe.
Okay, do you guys mind we're actually like trying to do this now? It is recording?
Yeah.
Okay. So everyone else is going to have to listen to your nonsense before we start this. Okay, so now this is the point where I'm actually going to start the actual video. I'm going to trim this other part up. So, all right, class. Now we're going to do notes for 3.3, increasing and decreasing functions of the first derivative test. Yes, that guy.
Do you have daily giveaways?
Yes, I do. Okay, I do. You have to look at my profile. It's Loot Crates on there. All right, so increasing and decreasing functions. Definition of increasing and decreasing function. A function is increasing on an open interval when, for any two numbers, x1 and x2 in the interval, where x2 is greater than x1 implies that f of, so the y values is this one, f2 is going to be, or f of x2 is going to be greater than f of x1. Okay, function is decreasing if that is just backwards. So, and if I'm reading it from x1 and x2, okay, as I plug it in, this is going to be greater than or less than. So, here's a better way to actually look at it. I like the graph. The graph actually helps out a lot.
It's like a wolf.
Yes, it is.
It's like a jawline.
A John.
So today, I was
Who's John?
Increasing and decreasing functions. Tests for increasing and decreasing. So, if a function is continuous on a closed interval. So continuous means what?
there's no holes, there's no jumps.
No holes, no jumps.
No kings.
Differentiable. Okay? Closed interval, A to B, and differentiable on the open interval. So you could take the derivative on the open interval from A to B. Okay, so if f prime of x is greater than 0, that means I'm taking the derivative, right? So the derivative is positive. It's going to be, okay, increasing over that interval. Now, if the derivative is less than 0, which means negative, okay, right here, it's going to be decreasing. So here's an example of a decreasing on the left, increasing on the right. And so if my derivative is equal to 0, that means it's going to be constant. So the slope is 0. So it's a constant slope. Make sense? Okay, so everything implies that I have to know the derivative or be able to take the derivative of the function. So, let's take a look. Okay, increasing and decreasing functions. Okay, locate the critical numbers and use these numbers to determine test intervals. Okay, to find the critical numbers, what would I do?
Derive and solve with 0.
Take the derivative, set it equals 0. Okay, so take the derivative, set it equals 0. It's almost like something you might want to write in there with that one. So take the derivative, set it equals 0. When I get that, that's going to tell me I'm going to have mins and maxes. So my first derivative is going to give me mins and maxes. So in between my mins and maxes, determine the sign of f prime of x at one test value in between each interval. So in between my mins and maxes, I'm going to pick points in between those and plug those in to tell me what I'm going to have. Okay? If it's a positive derivative, then that means what?
Increasing.
It would be increasing. If it's a negative derivative, decreasing. If my derivative is 0, that one's going to be a constant, but that's what we already did when we tried to find for 1. Determine the sign, test values, use the test of increasing, decreasing to determine whether increasing, decreasing, increasing or decreasing on each interval. These guidelines are also valid when the interval AB is replaced by an interval of the form. So we're actually writing it in this form here, interval notation. So it's going to be increasing or decreasing using these. Okay? So we're going to write it like that. So here's an example. Increasing and decreasing functions. A function of a strictly monotonic on an interval where it's either increasing on the entire interval or decreasing on the entire interval. So at this point right here, 0, it goes to 0 right there, right? It goes to 0, but then from 0 it does what? Increase again. So it's increasing to 0. So my interval would be from negative infinity to 0 would be increasing, right? Now, is 0 going to be a parentheses or a bracket? That would be a parentheses. Because the interval, yeah, because when it gets to 0, it's going to be a constant. So I'm not including 0, I'm going up to 0. And then on the other side of 0, I would have a parentheses. Okay, it's increasing, so parentheses 0 over to positive infinity. That's increasing continuously there. Now, here's another one. For this one, increasing to the constant, and then back up. So it's a piecewise function. So all this right here. So increasing to a 0. So it's going to be again 0 with a parentheses here. And then on the other side right here at 1. So from 1, parentheses, so parentheses 1 is going to be increasing again.
Wait, so how come that one is not strictly monotonic?
Okay, why?
Is it because it has an interval of 0?
It has to be increasing on the whole interval, but for the second one, it's constant.
It has this interval right here, in which that it's not. This one, it is increasing for the whole thing, except at that one point where it's actually going to be just a bracket to that, or a parentheses to that.
Is that the only
Okay, so that's the whole thing. Okay, it's just to that point, so it's all increasing over the whole thing. But at that one point, I get a 0. Okay, so on the other side of it, it's increasing again. On the left side of it, it's still increasing. All right, so right here, so that one is not. Now let's take a look. Increasing and decreasing functions. Find the open intervals of which this function is increasing or decreasing. So first thing I do is find what?
Derive.
Find the derivative. So my derivative, so let's say 0 is equal to 3x squared minus 3x. Very good. So I already have it set equal to 0, right? That's my first derivative. Factor, what am I factoring?
That's 3x.
So 3x, and I'm left with
3x times x minus 1.
x minus 1. So where are my critical points?
0 and positive 1.
0 and positive 1. So I'm going to do a number line right here. So 0 and positive 1, right? So we're going to look at different places. So this is what my interval is going to look like. So let's go ahead and take a look in. We're going to check some of these. So if I pick a negative number, okay, so a negative number, so these are my criticals, a negative number. Plug in a negative number here. So this is going to be a negative 1. So if I want to plug it in, so if I use negative 1, this is going to be negative 2, right?
Yep.
And isn't this going to be negative 3?
Yep.
2 negatives make a?
Positive.
So that means that right here, this is positive.
Then it's 2 rounds.
So that means this whole interval is going to be positive. All right, pick a number in between those.
0.5.
0.5, so 1/2.
3, 4,
1/2. This is 3/2, right? This is going to be 3/2, and this one's going to be negative 1/2, right? Yes?
Yes.
Okay, so it's a positive times a negative, which is going to give me a, so this piece is negative here. Give me a number on the other side.
2.
2.
1.1.
So this was, what do we say this one was? 1/2, and this one is 2. Okay, so let's plug in 2. This is going to give me a positive, right?
Yeah.
And this one's going to give me a positive 6, right?
Positive plus positive.
Positive, positive is?
Positive.
So my interval for increasing would be from where?
From negative infinity to 0 bracket.
To 0,
Parentheses.
comma.
1 to positive infinity.
How do I
With
open the 1? Parentheses. To what?
Positive infinity.
Decreasing.
Parentheses 0. Comma 1. Parentheses.
Do I have any constant?
No.
Nope.
Zero.
Make sense?
If it's constant, then it'll.
Constant's a 1 point. I don't have any interval in which that it's constant.
It's constant.
Okay, you guys got practice problems there?
Practice.
Practice.
Next thing.
It's a heavy.
Why didn't we do this like that last time?
There's a lot of things that we're trying to get done, but we can't get done because of time. Okay, right now I need you guys actually turning in all your homework right away, and that's not happening. So me going back and trying to give you a little bit more time on this. So if I got everyone actually working and doing their homework, this would go by really quickly. So, first derivative test. C can be a critical number function as continuous on open interval containing C if f is differentiable on the interval except possibly at C. Okay, so classification could be as follows. So it could also apply to if it's not differentiable at the point. If it's not differentiable, what type of problems do we have that are not differentiable at that point?
Absolute value.
Absolute value, right?
Absolutely.
Absolute value. It cannot take the derivative at that point, but I do have, it is continuous through there. But if I'm talking about the left-hand side and the right-hand side,
Those are differentiable.
yeah, those are differentiable. Okay, so right here, if it changes from negative to positive at C, then I have a minimum. If it changes from positive to negative, it is a maximum. If positive on both sides or negative on both sides, it is neither minimum or maximum. Okay, so if I was to use an example of a graph, I would go back to this. If it goes positive, positive, so this point right here is neither a min or a max.
There's no min or max.
No min or max on that one.
The mic still works.
Okay, so here's an example. My slope is negative and it's positive. This is a minimum. My slope is positive and negative. That is a maximum. This slope is positive and positive.
Neither.
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 Negative, negative. Neither. Make sense?
I think probably neither or neither.
All right, find the relative extrema of this over my interval. So, take my first derivative. 0 is equal to
Oh boy.
1/2. What's the derivative of negative sign?
Cosine. I mean, shit. I give up.
Negative cosine.
Negative cosine.
I'm
Are you okay, dude?
Wait, but the minus. So should it be positive?
No, because you're taking a derivative
Oh, my
of
bad.
negative sign is going to be it being negative cosine. Very good, right?
Even if you ignored the negative.
Or if you ignore the negative,
It's still
derivative
the
of sine is cosine, okay, times my -1, which out front
I
anyway.
feel like Liam's over right now.
Okay, so we have this, and my interval's here. So it's not going to be continuous because sine is a wave, right?
Yep.
So it have a whole bunch of places in which that is going to be mins and maxes. But on this one right here, I'm going to actually do the math. So get this by itself, so it's going to be cosine x
Is equal to 1/2.
is equal to 1/2. So now, on my unit circle, where is cosine positive?
On the
first
first and
and
third,
sec-
first and fourth quadrant.
First and fourth, right?
Four.
First and fourth. So quadrant first and fourth. Okay, so first and fourth. So in quadrant 1, where is cosine going to be 1/2?
Pi thirds.
No. Pi thirds.
Pi over 3. So in quadrant 1 it's going to be pi over 3. And, okay, so if I think about my unit circle,
Pi thirds.
so pi over 3 is up here, right? And so therefore the same value should be right here, right?
5 pi thirds.
5 pi thirds.
Can we do negative pi thirds?
50 over
Now,
4.
can I do negative pi thirds?
No,
No.
the interval is 0. The minimum is 0.
Because my interval is from 0 to 2 pi. So it's only positive, right? Only positive here. So we get those. So now for my interval. So on my line, pi over 3, 5 pi over 3. Okay, so if this is my derivative here, let's take a look. So for this, I'm going to plug into this one right here. I'm plugging into this one.
Pi 4.
Okay, so in between this, so on this side I would have
Pi 4.
pi over 4, okay.
I thought we could just do
Not
0.
zero.
I mean,
Can I include 0?
Fine, take
Yes,
the easy
no.
way out.
Can I include 0?
Oh, wait, no.
Okay.
Why? Why can I not include it?
Because it's past zero.
Thank you. So you said pi over 4?
Next best choice.
What's going to be in between pi over 3 and 5 pi over 3?
Pi.
Pi.
4 pi thirds.
And other side of 5 pi over 3?
6 pi thirds.
7
no,
pi
my-
quarters.
7 pi over 4.
Oh, no, no, no.
Or
Oh, yeah, yeah, yeah,
11.
11 pi thirds.
Oh, yeah, yeah.
What the heck is that?
7 pi quarters.
7 pi over 4, right?
Triple pi. That's
Yes? Well, look, right here. So on my unit circle, smaller is going to be pi over 4. And same thing here. This is going to be 7 pi over 4. So that's more than that. Okay, so now for this one right here. So at pi over 4, what is my answer?
Rad 2 over. Oh, it's 1/2 minus.
So it's rad 2 over 2, right?
Wait, isn't
so-
it 1/2 minus? No?
Yes, so it's 1/2 minus rad 2 over 2.
Yeah.
So which one's bigger?
Rad.
It is
2.
1/2 or rad 2 over 2 bigger?
Rad 2.
bigger too.
Rad 2 is actually going to be bigger, right?
Negative.
So it's going to be a negative. So this interval right here is a negative. At pi, what is cosine at pi?
Negative 1.
So it's going to be negative 1.
1/2 minus. Negative.
So 1/2 minus negative 1
Negative half.
Plus.
plus. It's plus 1.
1/2 plus
Oh.
1, which is
Oh.
positive.
Minus a negative 1, right?
3 halves.
Oh.
3 halves.
So it is positive, right?
Yeah.
Okay, so I have a positive here. And at 7 pi over 4, 7 pi over 4,
2.
it's going to be rad 2 over 2, right?
So it's negative.
So it's going to be the same thing that I had at the first one. It's going to be a negative. So that means that this one is a
Min.
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 min. And this one right here is a...
Math. Nailed it. Villain.
All right, you guys.
That's
Okay, you guys got practice on this? Hey, you guys, do you have practice? I gave you guys your homework. You guys want to actually go over any of the other practices? I'll go over them with you tomorrow. Okay. Your homework assignment, you have that?
Be sure to like, share, and subscribe.
Yes.